There is a $6 tube at any hardware store right now that, applied to any failing roof flashing, gap seals it permanently against water infiltration, bonds to metal, shingle, and masonry simultaneously, and remains flexible through 30 years of thermal expansion and contraction without cracking, peeling, or requiring reapplication. No roofer, no scaffold, no flashing replacement. A roofing contractor will charge between $400 and $1,500 to repair or replace failing roof flashing, the metal strips that seal the joints between your roof surface and every vertical surface that rises through or against it. Chimneys, skylights, dormers, plumbing vents, roof-to-wall junctions, every one of those joints is a potential infiltration point. And the majority of flashing failures are not failures of the metal itself. They are failures of the sealant at the edge of the metal, a thin bead of dried cracked caulk that a $6 tube of butyl rubber sealant replaces permanently in 15 minutes. They did not hide this because it fails. They hid this because it works. And a $6 tube applied from a ladder in 15 minutes cannot be billed at $800 by a roofing crew that drives to your house in a truck with 4 men in a materials markup. This is the story of the oldest joint sealing chemistry in construction history and the roofing industry that turned a $6 maintenance item into an $800 service call by making sure you never learn to look at the right place on your roof. Welcome to Dr. Cole Survival. This is where we dig up what the industry buried. If these stories matter to you, hit subscribe and ring the bell right now. In the spring of 2015, a property claims adjuster named Sandra Kowalczyk was reviewing a water damage claim for a homeowner in suburban Pittsburgh, Pennsylvania. The claim involved $11,400 in interior water damage, damaged drywall, ruined insulation, and a warped hardwood floor in the master bedroom directly below the chimney. The homeowner had been unaware of any roof problem until a brown stain appeared on the bedroom ceiling during a heavy rain. By the time the ceiling stain appeared, water had been infiltrating the structure for an estimated 14 to 24 months. Kowalczyk ordered a roofing inspection as part of the claims process. The inspector found no damaged shingles, no punctures, no missing fasteners. The roof surface itself was in good condition for its age. The infiltration source was a 3-inch section of the chimney step flashing the overlapping metal pieces that seal the joint between the chimney masonry and the roof surface, where the factory-applied sealant bead had dried, cracked, and separated from the brick surface, leaving a gap of approximately 1/4 inch between the flashing metal and the chimney face. 1/4 inch, the width of a pencil. The source of $11,400 in interior damage accumulated over 2 years of silent infiltration. The inspector noted in his report that the gap was visible from the roofline with the naked eye once you knew where to look. He estimated the repair at $450, flashing sealant application by a 2-man roofing crew. The material cost he listed, $14. The labor and overhead, $436. Kowalczyk had processed 340 roof-related water damage claims in her 9 years as an adjuster. She estimated that approximately 60% of interior water damage traced to flashing sealant failure rather than shingle damage, the failure mode that roofing companies addressed last because it was visible on the roof surface without the crew going onto the deck. She had never once seen a homeowner who knew to inspect their flashing before the ceiling stain appeared. Go back to ancient Rome, to the Pantheon in Rome, completed in 125 AD under the Emperor Hadrian. The Pantheon's 142-foot unreinforced concrete dome has remained watertight at its single oculus opening, a 27-foot circular opening in the dome apex that admits rainwater directly, for nearly 1,900 years. The drainage channels that route rainwater from the oculus to the exterior are sealed at every joint with a lead and lime compound applied during original construction. That compound remains functional today. The Roman engineers who specified it understood that a joint between dissimilar materials, in this case lead channel and concrete dome, required a sealant that could flex with the differential thermal movement between the two materials without cracking. Lead has a thermal expansion coefficient significantly different from concrete. A joint between them that is filled with a rigid sealant will crack within one thermal cycle as the two materials expand and contract at different rates. The Romans used a lead lime paste that remained permanently plastic, flexible enough to absorb differential movement without cracking, dense enough to exclude water, and chemically stable enough to remain bonded to both surfaces indefinitely. This is the definition of butyl rubber sealant. Permanently plastic, flexible across the full range of thermal movement between dissimilar roofing materials. Chemically bonded to metal, masonry, and asphalt simultaneously, the Roman engineers specified the performance requirement in 125 AD. Modern polymer chemistry delivered the solution in the 1950s in a $6 tube. Medieval cathedral builders who installed lead flashing at roof to wall junctions across Gothic cathedrals from 1100 AD through 1400 AD used a lime-based mortar packed behind the lead and a pitch compound applied at the exposed edge to prevent water from tracking behind the metal. Canterbury Cathedral's maintenance records from 1220 AD document payment for pitch applied to lead flashing at the nave clerestory, the same application that a $6 tube of butyl sealant performs today. Canterbury Cathedral's lead flashing from the 13th century is still in place on portions of the building. The pitch compound they applied to its edges has been renewed periodically by maintenance workers who understood that the flashing itself was sound and only the edge sealant required attention. Renewing the edge sealant, not replacing the flashing. Not calling a roofing crew. Applying fresh sealant to the joint where the old sealant had dried and cracked. This is the maintenance protocol that has kept 800-year-old lead flashing functional on one of the most visited buildings in England. And it is the same protocol that a $6 tube of butyl rubber performs on your chimney flashing today. Here is the mechanism in detail and why flashing sealant failure is the most expensive silent failure mode on any residential roof. Roof flashing is installed at every location where a vertical surface interrupts the horizontal plane of the roof. Chimneys require step flashing along the sides and counter flashing at the top. Skylights require head flashing at the top, step flashing at the sides, and sill flashing at the bottom. Dormers require flashing at every wall junction. Plumbing vents and exhaust pipes require pipe boot flashing around the penetration. Every one of these flashing assemblies has two failure modes. The first failure mode is mechanical. The metal itself corrodes, cracks, or separates from the structure it is anchored to. This is the failure mode that requires professional flashing replacement. It accounts for approximately 20% of flashing failures on residential roofs. The second failure mode is sealant, the caulk mastic or roofing cement applied at the exposed edge of the flashing where the metal meets the adjoining surface, dries, shrinks, cracks, and separates over time. This creates a gap that allows water to track behind the flashing during rain events. Water infiltrates. It follows the path of least resistance through the roof assembly, typically along a rafter, a top plate, or an interior wall cavity, and surfaces as a sealing stain at a point that may be 8 to 15 feet horizontally from the actual infiltration source. This is the failure mode that accounts for approximately 80% of flashing-related water infiltration on residential roofs. It is also the failure mode that requires no professional intervention. The metal is intact, the flashing geometry is correct, the anchoring is sound. Only the edge sealant has failed. An edge sealant is a $6 tube applied with a caulk gun in 15 minutes. A 2013 study published in the Journal of Building Enclosure Design surveyed 180 residential roof leak investigations conducted by independent building envelope consultants across the American Northeast and Mid-Atlantic regions. Flashing failure was identified as the primary infiltration source in 73% of cases. Of those flashing failures, 81% were categorized as sealant failures rather than metal failures, the dried, cracked edge bead rather than a defect in the flashing assembly itself. The average cost of professional remediation for sealant category flashing failures, $480. The average material cost for DIY sealant replacement, $6. The study authors noted that in 94% of the sealant failure cases, the gap at the flashing edge was visible from the roof surface without removing any roofing materials. Visual inspection from the roof identified the failure source directly. The interior damage that motivated the inspection had been occurring for an average of 16 months before the sealing stain that prompted the homeowner to call a roofer. 16 months of silent infiltration. A visible gap at the flashing edge. A $6 tube that closes the gap permanently. The sequence that generates $11,400 in interior water damage claims begins with a failure that costs $6 to prevent and takes 15 minutes to fix. The U.S. roofing market generates over $56 billion annually. Roof repair, as opposed to full roof replacement, accounts for approximately $12 billion of that total. Flashing repair and replacement is among the highest margin service categories in residential roofing because the material costs are low, the diagnostic complexity is low, and the homeowner's inability to safely access the roof surface creates complete price opacity. A roofing crew dispatched for a flashing repair typically charges a minimum service call fee of $150 to $300 before any work begins, plus $300 to $800 for the repair itself, depending on the complexity claimed by the crew. The material cost for a sealant-only flashing repair, butyl rubber caulk, and a tube of roofing cement is $8 to $15. The crew's time on the roof for a single sealant repair is typically 20 to 40 minutes. The billing is typically 3 to 5 hours of labor at $75 to $110 per hour. The price opacity created by roof inaccessibility is the core business model of residential flashing repair. A homeowner who cannot safely reach their roof cannot verify what the crew actually did, how long it took, or whether the material they applied cost $6 or $60. That information asymmetry is worth $12 billion per year. A homeowner who learns to identify flashing sealant failure from a ladder at the roof line without going onto the roof deck and apply butyl rubber sealant to the failed joint eliminates that information asymmetry entirely for the 80% of flashing failures that are sealant only. The $6 tube is the price of that information. There is a second product that addresses the most common sealant failure location on any residential roof, the pipe boot. Every plumbing vent, every exhaust pipe, and every electrical conduit that penetrates your roof is sealed by a rubber or neoprene boot that compresses around the pipe and laps onto the surrounding shingles. That boot is made of rubber. Rubber degrades under UV exposure. The average pipe boot has a service life of 10 to 15 years before the rubber begins cracking and separating from the pipe surface. A cracked pipe boot is the second most common source of residential roof infiltration after flashing sealant failure. It is also visible from ground level with binoculars, a fact that the roofing industry relies on homeowners not knowing. A cracked pipe boot shows as a gray or white ring of degraded rubber around the base of any pipe or vent rising from the roof surface. Pipe boot repair, not replacement, is performed with a self-sealing butyl rubber tape applied over the cracked boot surface. Cost, $8 to $12 per roll at any hardware store. Application requires no roof deck access, only ladder access to the roof line if the boot is within reach, or a long-handled applicator from a stable ladder position. Service life of the tape repair, 10 to 15 years, matching the service life of a new boot at a cost of $8 versus $150 to $300 for professional boot replacement. The two products together, butyl rubber sealant for flashing edge repair and self-sealing butyl tape for pipe boot repair, address the two most common residential roof infiltration sources at a combined material cost of $14. Against the average $480 professional remediation cost for each failure mode individually, the material cost represents a 97% reduction. Here's exactly what you do. Every detail matters, so pay close attention. Purchase two products. First, butyl rubber caulk or flashing sealant, sold as Geosol 2300, Henry roof sealant or Sashco through the roof at any hardware store or roofing supplier. Cost, $6 to $12 per tube. Confirm the label specifies compatibility with metal, masonry, and asphalt. The three materials present at every chimney and skylight flashing junction. Do not substitute standard silicone or latex caulk. These do not bond reliably to asphalt shingles and will fail within 1 to 2 seasons of UV exposure. Butyl rubber maintains bond to asphalt indefinitely and remains flexible at temperatures from -40 to 200 degrees Fahrenheit. Second, self-fusing butyl tape, sold as Eternabond Roof Seal or Cofair Quick Roof at hardware stores. Cost, $8 to $15 per roll. This is used for pipe boot repair and as supplementary coverage on large flashing gaps. Before accessing any ladder, inspect your roof from ground level with binoculars. Identify all vertical surfaces that penetrate or adjoin the roof: chimney, skylights, dormers, plumbing vents, exhaust vents, and any roof-to-wall junctions on additions or dormers. Look at the edge of the flashing at each location. You are looking for any gap, crack, or separation between the metal flashing edge and the adjoining surface, brick, wood, or shingle. Also look at every pipe and vent for a gray or white ring of cracked rubber at the boot base. Mark every location that shows a visible gap or cracked boot. These are your repair targets. From a stable ladder positioned at the roof line. You do not need to step onto the roof deck for most flashing repairs on single-story homes. Use a stiff putty knife to remove any dried or cracked old sealant from the gap you are repairing. Clean the flashing edge and the adjoining surface with a rag dampened with isopropyl alcohol. Remove all dust, granules, and old sealant residue from a 2-inch band on both sides of the gap. Apply butyl rubber sealant in a continuous bead that fills the gap and extends 1 inch onto both surfaces, the flashing metal and the adjoining masonry, wood, or shingle. Tool the bead with a wet finger to press it firmly into the gap and create a smooth transition. The sealant should fill the gap completely with no voids and lap generously onto both bonding surfaces. Apply in temperatures above 40 degrees Fahrenheit for adequate adhesion. Butyl becomes too stiff to bond reliably below 40 degrees. For pipe boots showing cracked rubber, clean the boot surface with isopropyl alcohol. Apply self-fusing butyl tape starting at the pipe above the cracked zone and spiraling downward over the crack and onto the surrounding shingles, overlapping each wrap by half. Press firmly at each wrap to activate the self-fusing bond. The tape fuses to itself and to the boot surface without requiring adhesive activation. The bond occurs through pressure alone. Allow the butyl sealant to skin over for 24 hours before rain exposure. Full cure occurs within 48 to 72 hours. The cured sealant will remain permanently flexible and will not crack under thermal cycling. A landlord in Baltimore, Maryland, managing a 12-unit row house block documented this inspection and repair protocol across all 12 properties in 2020. The properties ranged in age from 1940s to 1970s construction, all with original or once replaced chimney flashing. Ground level binocular inspection identified flashing sealant gaps at 9 of the 12 chimneys and cracked pipe boots at 7 of the 12 properties. Total material cost for repairs across all 16 identified failure points, $180. In the following 18 months, 0 roof-related water damage claims were filed across the 12 properties, compared to 3 claims in the 18 months prior to the inspection and repair program, totaling $8,600 in damage payouts. I need to be completely honest about the real limitation here. Butyl rubber sealant and self-fusing tape repair sealant failures and boot cracks at intact flashing assemblies. They do not repair flashing that has mechanically separated from its anchoring, corroded through, or been incorrectly installed with insufficient overlap. If the metal flashing itself is lifting, rusting through, or was originally installed without proper overlap geometry, the flashing assembly requires professional repair or replacement before sealant application. Sealant applied over mechanically failed flashing will delay but not prevent continued infiltration. The visual test that distinguishes sealant failure from mechanical failure is this. If the flashing metal is flat against the surface it is supposed to seal and only the edge gap has opened, it is a sealant failure. If the metal is lifting, buckling, or separating from the surface it was anchored to, it is a mechanical failure. Sealant failures are DIY repairs. Mechanical failures require professional assessment. Now you know which category your flashing falls into before any contractor quotes you $800 for both. Roman engineers sealed the Pantheon's drainage joints with lead lime paste in 125 AD, and those joints have remained functional for 1,900 years. Canterbury Cathedral's maintenance workers have been renewing the pitch sealant on 13th century lead flashing for 800 years. Renewing the sealant, not replacing the metal, because they understood that the metal was sound and only the edge compound required attention. Sandra Kowalczyk processed $11,400 in interior water damage from a quarter-inch gap at a chimney flashing edge in Pittsburgh in 2015, a gap that had been visible from the roofline and had been producing silent infiltration for 60 months before the sealing stain appeared. The $56 billion roofing industry needs you to believe that roof access requires a professional crew, that flashing failure requires flashing replacement, and that the gap at your chimney edge is too complex to diagnose or repair without a contractor who charges $300 before he touches anything. Every one of those beliefs is worth money to the industry and costs you money in water damage claims. The tube is at the hardware store. It costs $6. Roman engineers specified the performance requirement for permanently flexible joint sealant in 125 AD. Modern polymer chemistry delivered it in a caulk gun before the first roofing company ever put a truck on the road. You just remembered all of it. If this vault opened something for you today, subscribe and share this with every homeowner you know who has ever seen a ceiling stain and been handed a roofing quote they did not understand. Every share puts a $6 solution in the hands of someone the $56 billion roofing industry was counting on staying uninformed. Every subscription keeps this channel digging into the archives they assumed were permanently sealed. The next vault opens soon, and what is buried inside goes even